This showcase is brought to us by the community of practice of ISRIC, and we are glad to have you all join us this evening, this afternoon, wherever we are. This happens to be our 10th showcase for the COP, and it is the 4th for this year. And we are happy to have two great scientists and experienced researchers to share with us their work. Without further ado, I would introduce our speakers. Each one of them would be presenting their research. They have 15 minutes to do their presentation, of which there would be 10 minutes to discuss their presentation. The first one is Dr. Ermias Betemariam, who is a land health scientist with the World Agro Forestry ICRAF. He has over 15 years experience in research fields in land degradation and restoration, soil health and carbon dynamics, land use, forestry, biodiversity, spatial sciences, and environmental governance. Today, Dr. Ermias would be presenting on the topic, managing soil and biomass carbon in grazing lands, evidence, tools, and opportunities. Our second speaker is Mr. Kouame Anselme, who is an agronomic modeling and mapping, working with the International Fertilizer and Development Center, IFDC. And Kouame would be presenting on the topic, machine learning and crop growth modeling to spatially predict yield gap in Ghana. I would invite Dr. Ermias to take over the floor now and share with us his research work. Dr. Ermias, please, the floor is yours now.
Yeah, thank you. Thank you very much for the great introduction, Eric. And then, can you see my screen from your end?
Yes.
Yeah, wonderful. Then I think I also would like to thank the community for inviting me and then, share my thoughts, my experience. And then mainly I brought ideas from at least papers that I'm involved in. So I would like to share it's a kind of a personal reflection, so to say, in terms of soil organic carbon and grazing. So I think, why soil carbon? I think I don't want to really discuss that for this community because, everybody now realizes the central or the pivotal role that carbon soils in general, soil carbon in particular has been playing for the major global environmental benefits for food, nutrition, security, and you name it. So it is a hot topic. And then I think because it's a topic that it deserves, because it's not because it's a trendy, but it is really the basis where our economy is relying on. Yes, several initiatives. Oh, there's someone, you know how many initiatives exist every now and then. And then the very latest one, even in Africa, fertilizer and soil health action point. And then, I think soil health in general and then soil organic carbon is really taking huge momentum. Yes, I think it's also good to have, before we zoom into our watersheds, our landscapes, or our farms, I think oftentimes it is really good to have the global outlook. Where do we really find this organic carbon in high quantity, and then why? I think this would be very interesting. Then we can zoom in into a specific place, because sometimes we go to a small watershed or small area and we would like to interpret it. But I think soil organic carbon, soils in general, having a global distribution and then understanding that global perspective is really useful. And that's why we also really thank ISRIC to be the global, database in terms of when it comes to soils. So I think it would be too good to have that holistic perspective whenever possible. Yes, on the same note, and then I think we discussed a lot in terms of land potential. In which system are we talking about? Like in the drylands of the Sahel, for example, where do we expect much of the carbon to be? Is it in the soil? Is it in the biomass? So it depends where we are. And then there is already, a process by which in certain biomes you expect much carbon in the soil than the others. So that's why our expectation oftentimes depends on where we are. So it is extremely important to also consider, in which kind of biome or in which kind of system that we are really thinking and talking about biomass and then soil carbon stocks. Then I would like to zoom in a little bit on the grazing lands because I have a bit of oversight because, for food and then feed and then all these kind of things, people tend to have a lot of research on the forest side, a lot of research on the agricultural lands, but grazing lands are oftentimes, particularly in Africa, are less studied. And then also, the pastoralists, we know where they live. And then I think that, socio-ecological system is not well studied. So I would like to take you to two use cases where we have a project, one in Burkina, and then another one is also from Ethiopia. So I would like to share one of the experiences. One in Burkina Faso is about the impact of fire. On the Ethiopia side is also the impact of grazing management on soil organic carbon, which was a very interesting project where INERA from Burkina Faso was also part of this project, and ILRI also from Kenya. So on the first one, in the Burkina side, that is me, like, maybe 10 years ago. I'm older than that picture that you see. So we really try to have, I really like to acknowledge also Burkina Faso for having in Tiago and Laba with INERA, having a long-term observatory sites by now it could be close to 30 years or 25 to 30 years, by which every year they will experiment with fire and grazing intensity. And then I have never seen this kind of long-term observatory, real experiment sites happening in the continent. So that was a very nice. So I was there during the 19th year of the management. And then the key thing that we compared and observed is that people thought that burning is going to affect the soil organic carbon. People thought that, reducing grazing pressure is going to also, disfavor soil organic carbon. That is what people say. And then what does the literature say? That's what even the models sometimes assume. Then in this study, interestingly, we find even I start also putting a very negative titles, I'm sorry to say, because there is a bit of conformity bias on people when they're reporting, when they're finding, not if it's not significant, they drop it. And then, there is a tendency of publishing interesting, significant difference, very good R square kind of thing, focus too much on the mean, ignoring the median. So there are a lot of biases to these positive stories anyway. So that's why even I start to say that, when we don't have any significant result, let's be really bold enough to talk about it so that people could learn, expectation could be also managed. So that's why I said no change in soil organic carbon and nitrogen following long-term prescribed burning and grazing. But that doesn't mean that this is about soil organic carbon. If someone wants to really show by managing my grazing land this way or that way, I will get more carbon in the dryland system in the Burkina case. It didn't, then because we couldn't find any result. But that doesn't mean that you have to continue burning. It doesn't mean that you have to go over grazing because there are a number of other ecological, socio-ecological things behind it that we need to consider. But when you think about soil organic carbon or carbon markets, the most interesting commodity is carbon. And then if you really promise these kind of things to happen in the system, it might not be really the case oftentimes. So we found no difference in burned and unburned, closed management and open plots. And then, maybe if you ask me reason why, and then as I go, because the grazing land systems, they have their own unique way of, managing carbon in the grazing systems. So when you have a lot of biomass in above ground, and then you will have less carbon in the soil because most of the carbon might be taken into the biomass. So that's why when you really cut it or burn it in this case, or harvest it, so to say, the above ground, you always encourage the root system. So the root shoot ratio really matters most in the grazing systems. So that's what called carbon reallocation. So from the biomass, when you remove the biomass, because from the litter, decomposition is low because moisture is very low in the dryland systems. So most of the carbon is coming in balance, although small it is from the rooting system. So removing the shoots also oftentimes encourages the root carbon system. So that's why when we go like in a Serengeti or like, for instance, in the River Mara, you see like millions of herbivores are moving and then destroying. If you look at it, you can assume that it is degraded, but they will give it rest and then they go to Kenya. Then following the season, they go to the migrating to the wildebeest to Tanzania. So that is a natural process by which one time intensively for a short period of time, and then livestock also give, convert, balance the carbon nitrogen ratio, because if you just have carbon and you don't have enough nitrogen in the system, that's not also okay. So even one very interesting indicator is not carbon, it's not nitrogen. Sometimes the carbon nitrogen ratio could be also a very good indicator. So when you remove the above ground, you always encourage carbon in the system in the dry lands. Well, I mean, something which were not also well studied is the impact of termites. I think that it has a very local kind of impact, but I think termites also play a very interesting role. But are they really converting carbon into the system, or they're really transporting from the deeper soils to the horizon? But I would say, I think, that is also an area which really requires careful study, particularly in the dry land grazing land systems, because, termites are more common in Burkina Faso, for instance, where we studied. So when I take you to the case in Ethiopia, in this case, it's not fire, but it is about reducing, livestock grazing, by which communities close their communal grazing lands, and then there is no direct free grazing, but they allow only maybe young calves or also cut and carry kind of thing, but it is not really managed intensively. And on the other hand, it is open grazing. So in this case, we really found an area where about 14 to 36 years old of exclosure land management, where Ethiopia is really well known for. Then you say that, okay, these communities have been closing their grazing lands. They will have like you can call it like a fodder bank. And then that management, what is the impact of that kind of management compared to the open grazing on soil organic carbon? Then oftentimes people or environmentalists might assume that when you really reduce the grazing pressure, perhaps the carbon could increase in the soil. Okay, as a researchers, we shouldn't have any bias, and then we go like, we have a pairwise comparison with as much as possible in natural resources. You don't get enough replication, unlike agronomy. But I think still we use like space for time substitution in this case, because we don't have baseline. Oftentimes we lack baselines. That's the chronosequence approach that we followed. And then the result we found also in this system is that, controlled grazing didn't show a significant change in soil organic carbon, but observe the erosion, for instance, in the right side, in the open one, erosion. So that's why if you want to measure carbon only, you might not see the impact of the management. But when you add, for instance, erosion or biodiversity into it, it might be very significant. So the implication of not finding a significant difference between the two systems doesn't mean that one management is better than the other. That's what, a lesson we picked from the case of Ethiopia. So I would like to take you also a little bit on the remote sensing side of work that, I also led in Colombia. This is a map of Colombia. Sometimes it is also good to learn from other systems. So the very interesting silvopastoral systems they have in Latin America. So, we say that, I never been to that site even. And I say that, okay, there was a project who would like to be interested to increase tree cover in the silvopastoral systems and then have more carbon and more things. It used to be like that. But people tend to turn that agroforestry-based grazing or silvopastoral system into, grazing-based only, so reducing trees. So if you want to reverse, what potential that particular have. So in this case, we divided, Colombia into. We go for, like, for instance, where are the grazing lands? Where are the different agroecological systems, zones, if you watch the biomes, because every biome have their own potential. So, and then by taking data from remote sensing, in this case, tree cover, MODIS image, and then, try to use also IPCC default values to convert that into actual biomass carbon. So that, in that case, even before we go some places, I think we need to also, use this kind of remote sensing techniques, by which if you look at the map on the right, it shows you where is the area where we have soil organic carbon below the 25 percentile, then below 25, huge vary. Then if you are really targeting even the median, that is 25 to 50%, you have this much land. So this would be very interesting for spatial targeting, realistic targeting. And then this percentile is not coming from outside. Just by doing the measurement within, there is a distribution. That's why I am more interested on range, median, and distribution in ecological systems. So if you take the range, for instance, in agriculture, one farmer is producing 5 tons per hectare. Maybe a farmer next to him is producing 3 tons per hectare. So that will tell you that they are in the same socio-ecological, so ecological system at least, but there is a bit of a gap. So we're trying to really create a gap within the existing system so that you can see the distribution, and then if you target some places to target to achieve in the below the 25 percentile, and then how much area I have, and then that could be a modest target, but if you achieve that, even it means this much kind of CO2 equivalent. So this kind of analysis is also very could be done. And then also we wrote a very nice paper on the role of drylands in carbon neutral world. They play a very significant role. And I don't want to mention a lot on this, but if anyone interested also could read it, because it's an interesting piece of work that we did also on dryland carbon. So, because oftentimes, coming from, staying for 15 years at the World Agroforestry ICRAF, and then oftentimes we are biophysical scientists, and then we like socioeconomists coming into this play. So this is this is a paper that we produced with economists, and then we took them to one part of Ethiopia where they do restoration. So I think what is really the most limiting element, or where is the high value information exists? Is it like in the carbon? Is it also in the carbon market, or this kind of things? I think it would be also very good to have the social and the economic figure into carbon would be also very interesting. Then if you want to really simulate, this is stochastic impact evaluation, then because restoration projects takes decades, and then Alima, you might mention, you might know like ex-ante analysis. This is a kind of ex-ante analysis. So our evaluation is not based on what we know, but we are also predict the potential outcome. What do we expect from this kind of socio-ecological system? Which kind of social interventions, like beekeeping or fattening of livestock, which one would really give enough return over decades? This kind of economic simulations, and then considering the biophysical potential of region of interest could be also done, because this could help us quite in advance during early stage of the project is to really what do we expect. Then that would be kind of research that we need to also consider in this kind of thing. For example, in one of the projects that we found in this project, as I said, is not about the carbon. The most uncertain variable in the whole carbon market that we found is the carbon market itself. It was very volatile by then. Even now, it is a promise, but sometimes it could be an empty promise, because sometimes it might not work. So, the other paper that we also wrote in Africa before, that is USAID by then. Now it doesn't exist, sorry for that. So they would like, before they invest on grazing land, carbon, they really want us to understand what is known and what's not known. It was a report, but we converted into a paper finally. So some of the key knowledge gaps also, it depends where we are. By then, now some of them might be answered, was like, for instance, the rate of carbon sequestration and the saturation levels. Because sometimes environmentalists thought that when you improve this one, when you increase carbon, keep increasing. No, there is a saturation level, and then also sequestration is not like happens everywhere at the same speed. So those, for the different biomes, I think understanding this carbon saturation and the sequestration rate would be interesting, and then that's very not well studied, so to say. And then the impact of land use change on soil organic carbon also. We still there is an assumption. The models still assume when you change this to this, it will happen. This is what's going to happen in soil organic carbon. Oftentimes, that might not be the case. Yes, I think this is my last paper to say, because this is a topic even I picked, and then this is the review paper, which is high impact journal, and then we really make a very interesting review. I encourage people to read. So soil as a carbon store sinks, expectation patterns and processes in the prospectus. So we really summarized everything that we know so far until the year 2026 in terms of soil organic carbon. And then it is a very interesting review paper that I would really encourage people to read. So I think the basic things, one example is really having the below ground and above ground carbon storage and systems, how they interact among each other in the different biomes is really critical. Because sometimes when you say carbon stock, it is about not only the input, but also the mean residence time, because sometimes carbon comes in, it goes out. And then is it stable carbon? If it is for climate change, you need to have a stable carbon. If it is agriculture, you need a carbon that can decompose. We don't need organic, but because we need, nutrients in organic form for the plants to consume. So it depends also the objective. In agricultural landscape, it's not like the residence time, but in the climate could be something that. Then we need to understand which systems are really interested. So I think the key things from that paper also, you might get more insight, is really soil organic carbon is a small fraction of the soil biomass, but it is really playing a very pivotal role in terms of climate change mitigation, biodiversity, land, and then even hydrological properties, and then you name it. So transitions toward the soil organic carbon recovery depends both on the biophysical and the socioeconomic drivers. So if you really consider only the biophysical things, and then if you want to consider the socioeconomic, either part is incomplete. But as much as possible, I think nowadays I'm very happy. People are thinking like in a system, and then the system works like when you have a different components, and then bringing both the socioeconomic and the biophysical teams together in this topic would be more exciting. And the policies, particularly environmental policies, are and then have big expectations. However, that's not really oftentimes the reality on the ground. Then I remember, in Kenya, people go there, oh, this is the rangelands in the northern Kenya. This is tremendous. And then, some people say this is where the solution for climate change mitigation is. But what is the carbon holding potential of that particular area? Could be 1% carbon. Then if you add anything else, it may not be beyond its carrying capacity. So that's why, like any other system, we need to know what is the carrying capacity in terms of even carbon itself would be very interesting to consider. So the key lessons I would say that I picked is really, effects of burning, exposure, grazing, land management on soil carbon are highly variable, and then no generalized evidence. That's why tendencies and evidences. And I think we need to keep improving and sharing more data together. And then whenever we have opportunity to do research, let's not really repeat what is being there, but we need to really understand some of the gaps and then invest on those gaps so that we can have a comprehensive understanding. And then, of course, in terms of intervention targeting, I think target for multiple benefits, because oftentimes I have been into several carbon-related programs and then meetings. Then we always tend to conclude that I think let's really consider soil organic carbon as a co-benefit. Sometimes bringing it upfront, it depends on where you are, is okay, but oftentimes it's not really in terms of the market itself, but it's about the livelihood options. It's about how to make the system resilient, sustainable, and productive. So that's really much important, because the role is not always seen from the climate change mitigation lens alone. Then it would be also easier to probably cheaper to conserve than restore. So that's why one of the very scary topic in this continent I have seen is restoration, as if it is a very simple thing to do. It's not an easy thing. So that's why if you really degraded the grazing land, particularly, they are resilient. But once they are degraded, you cannot easily reverse them. Why? Because moisture is not there. The whole system can collapse. If it collapses, and then sometimes it is impossible even to restore it. You can rehabilitate it, but it is very difficult. So that's why we have to understand some of our key ecosystems by which they look very resilient, but once they really pass that threshold, it will be very much difficult to reverse them back. So the best thing is, I would say, let's really try to identify them, avoid degradation, reduce degradation, and then when it's not possible, reverse. But now the effort I have seen is that most of the projects are moving to restoration, and then we might forget about the conservation. When people told me that about 60% of the African lands or 65% of the African land is degraded, I always ask them, can you give me the map which is not degraded? Because I'm more interested on protecting those healthy lands instead of really focusing the one which are already bleeding. So that's why I think we have to be careful in this. I would say a number of people talking about restoration, but we have to be careful about to keep what we have safe, then we go others to join. Otherwise, it would be, we might also end up losing the ones which more or less are really producing, or they looks like healthy. And like the case in Burkina Faso, I think then it would be really interesting. I know some also in Ivory Coast, Cote d'Ivoire also have these kind of things. I think we need to have key learning in observatory sites, and a long-term observation is very important, because that would help to sharpen the models, and then also to have more realistic evidence. So we have to make the right balance between measurement and modeling, because both are equally important. Yes. So this is my last slide. Apologies if I take a bit longer than I thought. Then I think it would be very good to consider land potential and then be a little bit site-specific solutions. And then if you ask me, for instance, where is the best place to invest if you have a carbon system or carbon market? And then we know the place where mineralization is less because carbon will be stored as carbon, organic form. It will not be converted into inorganic form. And then these places are like cold, moist climates. That's why I showed you which biome has this kind of behavior. Then if you invest on that kind of system, it may work. Input rate were high, and then like if I took you in the humid Cameroon, for example, if it is degraded a little bit, if it is not saturated, and then you can have, a lot of, the biomass that you see could be converted into carbon system, more or less. So we need to also understand which systems could respond for our management quickly than the others. Yes, and then of course, like a little bit on the right side, if you look at, and I was really trying to observe the NDVI map of Ethiopia over a decade. And then I was so impressed when I see a lot of green areas from any DVI perspective. You thought that it is, more biomass or more greenness is happening because it measures the degree of greenness. And then when you see red, I think that's the vegetation is really degrading. And then I think in this case, when you see in the left side, top left side is more red, and then lower and then eastern side is more green. And then someone could interpret this that, oh, the eastern and southern part of Ethiopia is getting green, while the highland is in the right and then the left are really gaining. But if you know Ethiopia, for me, because I know it, the left side is right because vegetation is degrading, but the right side, which is getting greener, is a gain. It's also degradation. It's just because of bush encroachment mainly in the drylands. So that's why when you come to the Horn of Africa, when you go to Namibia, and then if you don't know the place, and when you see a lot of positive changes, no, it looks like positive. We call it even false positive. That means it looks green while it was not supposed to be really green because it was supposed to be grazing land. But now we have a lot of biomass into the system. And then even most of these areas, people are even tending to convert from the grazing system into the browsing system because they are producing more bushy systems. So understanding the system is very important. And then also that could help us also what to expect. So these are the references also for someone who are interested. I have also shared the presentation with Eric, and then thank you very much. And then I really appreciate for the opportunity. Over. Thank you.
Thank you, Dr. Betemariam, for such an insightful presentation. And congratulations for the great work done over the years on soil organic carbon and trying to understand how we can manage it because it's really important for our agriculture. I would now pass the floor for participants to ask questions. I know there is a lot to discuss. So please, you can raise up your hand. We have 5 minutes for questions for Dr. Ermias to answer our questions. Okay, Dr. Sam, please take the floor.
Okay. Thank you very much, Dr. Ermias, for this beautiful presentation. So, and I truly enjoy it. So it's more of just to highlight some few points and then ask a question or about a clarification. So thank you. The message on the need to conserve the soil is well taken, that the focus should be more on the conservation than trying to find the degraded areas that to restore, because the restoration effort is more challenging, even though at one time or the other both are actually needed. And the recommendation of the long-term observation, so that at least we can have big data to have evidence-based recommendation on this soil carbon sequestration is needed. However, the question on that is what efforts can we do, or will you recommend as a community, or are you presently doing at ICRAF in this area, in the area of long-term observation? Then the second one is that the result from Burkina Faso, it actually looks interesting that despite the exclusion and the fire, there was no change in soil organic carbon. And of course, I know in the paper you attributed to some reasons, but I was just taking at it and looking at it closely now. Don't you think it could actually be related to the biomass, the quantity of biomass? Because in the end, if the biomass you have is very little, and you burn or you leave, it does not really make much difference. Don't you think it's more of biomass intensity or quantity? And then lastly, on the map of the beautiful map of Ethiopia you show, that looks quite nice. I'm a bit familiar with Ethiopia too, not too much like you come from there, but if you look at that map, you see that in a way, it's actually more or less relates more to the land use, because you see that the highland area, those are the red areas, and the lowland areas of Ethiopia, that is where you tend to have the green. That does not necessarily say it is much better, but I see that the maps relate more of to land use, looking at the highland and the lowland area of Ethiopia. Thank you very much once again.
Thank you, Dr. Ermias. Dr. Sam, thank you for your question. Dr. Ermias, please.
Yeah, I think I absolutely agree with you, because I think one is, I think to have this kind of community is also really to think carefully about, not about listening on the presentation in the science, and what could we do together. I think that's very important. Like, we have universities, we have national research institutes, and then also in Africa, what I have seen is that we always tend to depend on donor money. Like ICRAF is dependent on donor money. Then I don't have money, I don't have job. If I don't have job, so let's not really expect a lot from the CGIAR kind of international organizations. I would be very happy if the national system itself invest on this kind of research, because it is their own land, their own system. So that's why I think there should be a commitment, because the whole initiative in Africa for the last 2 years in every sector. But when you ask all the governments in Africa, even to pay the 10% for CADEP, they failed to do so. So we need to also push our governments, our system, to really bring basic funding for this kind of long-term observatory systems with our knowledge. If you go to France, they will not wait any budget from EU. They do it themselves. So oftentimes, there is also what you call the concept of the living labs. Even if you don't have a lot of things, we can also learn a little bit of sites that we can regularly go in and visit. And then I think that's how we need to change our mind first behaviorally. And then finally, we will really look for, because oftentimes people tend to have, I don't have money. It's not about money. It's about the mindset, so that, let's do this, I think, in few selected sites, and let's push also our system to fund this kind of, institutions and this kind of long-term observatory. Otherwise, most of the work, as you said, if you ask me how many of these papers that we wrote are based on, money coming from Africa, almost none. But on the other hand, if you ask most of the African government, they spend millions and billions when it is really coming to the military or stuff like that. So I think, we need to keep pushing also our national system to really, invest on this kind of things. And then let's consider the donor money as a complementary. That is, I think, very critical. And the first thing is our mindset. Then we do it. And then I'm absolutely right. In the Burkina side, a number of reasons. Of course, biomass plays a key role, and then not only biomass, also in terms of also the soil microbial activities, which also keeps the whole mineralization process, even the temperature. And then also, the whole thing is a whole system. That's why it would be really interesting to have like a process-based models and then understand how each one of them are working. And I'm absolutely right. But when it comes to the biomass, however, in the dry systems, even if you have a lot of biomass on the above ground, it might not translate into soil organic carbon. That is a message, because much of the organic carbon in the grazing systems of the drylands are coming from the root biomass. So if you go to the root biomass, but how many of us are really studying the root biomass in the grazing systems? But we are always trying to measure what is on the surface. So we have to dig down and then also understand what is really under the process, underground process. I think that is also equally really important. And then, yes, the Ethiopian case in highland, lowland, yes, that's why most of the lowland rangelands are really affected by bush encroachment, which is a very critical challenge in Somalia, in Kenya, and then, these more invasive species. And if you go to even, the dryland grazing systems of also Namibia. So that's why I don't want that kind of thing to come further through Chad and Mali and then affect the Sahel gradually. So we have to be careful also on managing invasive species. We need to understand them and how they are really doing and affecting the grazing systems. Because the moment the system favors woody biomass, the grazing systems collapse. It's not about degradation by itself, because there is always a natural selection by which grazing land is supposed to have much grass than biomass. Then the moment the system favors or degradation favors the coming of woody biomass into the system, the grass are very shy and then they run away. So that's why we have to really keep that ecological balance as much as possible. And then we need to interpret those things very carefully. Absolutely right, Sam. It is a highland, lowland issue, but that's why I said, spatial, context understanding using remote sensing, this kind of things also could further help. And then if we make the right balance between our measurement and modeling effort, and then even local knowledge, expert knowledge, there is huge, then we need to also really understand, those things. Thank you very much. Otherwise.
Thank you, Dr. Ermias. Dr. Alimata, please, you can open your microphone, yeah.
Yeah, thank you very much for this insightful presentation, Ermias. And I really like the results you presented. So my question would be on the carbon crediting aspects. Yeah, from the results you just showed, we saw that it is very difficult to restore the soil than conserve. So, and we know that nowadays we are talking more about carbon crediting, and we are saying that, yeah, Africa can benefit more on this. So since 60% of our land is degraded, and we know that it's difficult to restore them. And in your thoughts, you were saying that we should emphasize more on conserving the 30%. So I want to know where can we emphasize our action to benefit from this market, since we know that the carbon conservation restoring is very difficult. How can we really benefit from this opportunity?
Yeah, I think, for me, I think it's a valid, very practical thing. That's why even on the last message, there is a lot of optimism on the carbon than what is happening on the ground. So that's why we have to be more realistic in terms of where should we benefit from carbon, because you reminded me of, the first postdoc assignment I was given at ICRAF is to come up with, a robust soil organic carbon measurement protocol, so that like the whole mid-infrared spectroscopy at ICRAF, and then all guidelines, and then we did all those things. Very interestingly, I did even a very good economics, a quick economics of measuring soil organic carbon. And then for organic carbon, we need to have a staff to plan the field measurements. Someone need to have a vehicle for oftentimes to go to the field. You need a driver. You need auger sets. You collect soil samples. You have to dry them. You have to process. You have to send it to the lab, analyze it, and then you get the result. Then I really make a calculation how much it costs, including fixed cost and then also variable costs. And then finally, where I was impressed with that, the cost of showing that you have enough carbon in your system is much more higher than the carbon credits you can get. So it is very, very interesting, because you spend a lot of money even to show how much carbon you have into your system. In the carbon system, if you are very strict, then the carbon itself. By then it was like $10 per ton of carbon. But to show in your system you have enough carbon, if you go like the gold standard of all the measurements, how much will it cost you? Then we never really consider the economics of soil organic carbon by itself. So that's why we always talk about the benefit side of it, which is exciting. But what is the cost of that? And then what is even the evidence that you'll get that much carbon? Or are we kidding ourselves? So in general, in the grazing systems, in the dryland systems actually, that's why it will be very difficult to really get a very reasonable carbon gain into the system. In 10 years, 15 years, we know it. Even sometimes 30 years, you may not really get a detectable change, because sometimes how precise are our measurements? They are not precise. It's not like gold, because if you take these samples to different labs, you get different results. So the variability is so huge. So it could be a noise. And we don't have even a very standardized method of doing it. So sometimes the comparison, you see differences because you may use two different measurements, so that you can really, it will be a confounding variable. I mean, this is a scientific community. We have to be really focused on the evidence, and then we know where we should expect. So that's why there are certain ecosystems by which in these systems, if you invest in carbon, I could get something. That is, where is the suitable variability of our landscapes for carbon, not everywhere. And then if you have $1, where do you want to do it? Where you have high return on investment. That means when you plant one tree, and then you get a bit of carbon into the system. So where is that? So I think we need to also consider return on investment and actually also understanding the carbon potential. The other thing in terms of payment is that we need to change the narrative. It's not about increasing carbon. It's about sustainably managing the system, keeping the system to be resilient and productive for millennia for the next generation as well. Then in that case, people should be paid for taking care of their land. It's not about really bringing carbon necessarily into the system. How about avoiding carbon loss by itself? We never thought of. We are talking about gaining of carbon. How about avoiding loss of carbon by itself? It's almost a gain. So the whole equation narratives along that, REDD+ and all these kind of things, we know them, but we need to really help in and understand and help our countries and our people understand that thing better. Otherwise, if you have like a natural forest, you will not be entitled for REDD+ because it's not degraded. Oh, okay, let me go and degrade it. And then if it is degraded, I will restore it, I will gain. And then some of them, they have even unintended outcomes. So let's not really drive by the carbon. I think let's take carbon as a co-benefit. What we need most is really to make a resilient, sustainable, and productive system. Then after all the system, if we gain any carbon, it's a plus. If not, we gain what we really wanted from that system. And then in terms of negotiation with the climate market, it's not all about carbon gain. Also, we really help the system not to lose. We should be paid. And if farmers are managing their land nicely, they need to be incentivized in different forms. Which otherwise, if I give you carbon, you get this one, I pay you for that one. It's a little bit a very mechanical kind of market system for me, which I really don't support because even evidence doesn't show you from the biophysical study that we have been doing. But bringing the economics of carbon, that's why we did the case in Ethiopia. You can read the paper, also could give you more insights. A topic by its own for next time, perhaps. Alima, thank you.
Yeah.
Thank you. Thank you,
Thank you
Dr.
very
Ermias. I'm afraid we have to move on to our second speaker. If you have any further questions for Dr. Ermias, please kindly put in the chat and we would answer it for you. I would invite Mr. Dr. Ermias, please, thank you for the interesting presentation before I move to Kouame. Kouame, please, you are welcome to share your slide. Kouame would present on the topic, machine learning and crop growth modeling to spatially predict yield gap in Ghana. Kouame, please, you have the floor now.
Yeah, good afternoon again. I don't know if you can see my screen. Can you
Yes,
see it?
we can see yours. Yes, we can see it now, but you have to put it in presentation mode.
I think it's all right now.
Yes,
Okay?
it's all right now. Yes, thank you, Kouame.
Yeah, okay. Okay, thank you so much. Maybe I'm not going into detail like Dr. Ermias did. He's a senior. I'm still scratching the surface also to be at his level. Yeah, but we will try to dive into the work that we have been doing in our team, the Ferrari team in Ghana, which is about using machine learning and crop growth modeling for spatially predict yield gap in Ghana, but also beyond. Yeah, my
Kouame,
name
please,
is.
can
you hear me?
you turn your video on so we can see you?
Oh, sorry.
Okay, thank you, Kouame.
Can you see me now? Yeah. Is it okay?
Yes, we can
Yeah,
see you.
okay. Yeah, thank you so much. Okay, then what I'm going to show here is a specific case of Ghana, but I think we can reproduce it beyond even everywhere in the world. Okay, the generality here is like in Ghana. Okay, yeah, in Ghana we have that the economic situation of Ghana is based on agriculture, and the agriculture is accounting for around 20% of the GDP in Ghana, and I think it's almost the same thing in almost everywhere in West Africa, and even the sub-Saharan Africa. It is almost the same thing. Agriculture is driving the economy. And it's also involved almost 40% of the workforce in the country. And this is what support the food security in our country, though we are still insecure in food production. And in Ghana, specifically, maize and soybean rice remains the most important staple crops. But unfortunately, the yield for those staple crops are really below their potential yield. If you take the maize, for example, in Ghana, the average yield is around 1.5 to 2 tons per hectare, which is from MOFA. And the potential yield is around 7 to 8 tons in Ghana. And this creates this suboptimal yield contribute to food insecurity. And we have around 1.2 million people that are insecure, and which puts the burden, or which is put around 2.2 million people at the risk of food insecurity. According to the research, one of the means that people can use to increase staple crops yield is a fertilizer application. And we have a bunch of articles, a bunch of research that show that fertilizer would really improve maize, soybean, rice productivity in the country. But to do so, we have to site-specific apply fertilizer, following the patterns, the nutrient in the soil distribution pattern. Then we need soil information to do that. But the problem is, like, we have a critical gap of soil information in Ghana. And it's the same thing as the whole West Africa. And a bunch of studies have shown that gap in Ghana. For example, we have that QS and DOE have shown that several studies focus mainly on growing cocoa growing zone in Ghana. But even with cocoa, we still have a lack of soil information to guide farmers to apply fertilizer to increase these cash crops. And we have also limited information available for non-cocoa area, for example, in the northern part of the country. And most of the soil map that we have are coarse. They are most higher, above 1 kilometer of resolution, which is quite difficult to get a site-specific fertilizer recommendation. And also, if we have a soil map that's showing the distributions of the nutrient or soil's nutrients, the data is unevenly distributed. For example, is the case of ISRIC maps that Engel and Hart have produced. And they are not really taking into consideration the agroecological zones, depending on the crop that are cultivated on those zones. For example, this is a simulation graph that we made using QuEFT models, which is helped to recommend fertilizer in the tropical regions. And as you can see here, we use ISRIC data, and we poorly estimate the yield over the countries. You can take, for example, the figure B. We have in the Guinea Savannah, the explanations power of the QuEFT model is just around 30%, and in the transition zone is around 19%. In the deciduous forest, it's just about 44%. And this is very low. And we need data, accurate data, to come up with, to fit our model, come up with site-specific fertilizer recommendation. And in one of our papers that I will be showing in a few minutes, we try to come up with high resolutions and national representative data for a couple of key soil proxy soil mapping, and we have developed it at 250-meter resolutions of soil pH, soil organic carbon, the cation exchange capacity, like the most important soil parameters that we need to predict the yield that will we need to predict the, how can I say it, the fertilizer recommendations. And also we evaluate the accuracy of our map that we produce against the continental product, the one that has been produced by ISRIC, but also by ISDA. This is a quick summary of how we collected the data. We collected around more than 18,000 data, and from ISDA, because ISDA is working also with Ghana institution, IFDC, and we have also CSR, we have OCP, and all those data are being analyzed using wet lab. We didn't use dry. You harmonize the data from 0 to 30 centimeters and using two different approach to predict or to model soil nutrients. We use the equal area splines and the weighting average method. We standardize the measurement and convert units for consistencies because they are all from different sources. This is very important to come up with accurate map. We extract data from remote sensing database, the terrain data, climate, vegetations, and this is the land cover. And we resample all these covariates using the bilinear for continuous and nearest neighbor for categorical data. And we model our nutrient using the contra-random forest, which is the most used one in terms of data soil mapping, though people are still using grazing, the geostatistical models for soil mapping, but in our case, we use the random forest. And we split our data in 80 to 20. We use the 80 for training and 20 for testing our prediction. We use the recursive feature elimination and we evaluate our model using the statistical metrics. And these are the outcomes. Oh, sorry, don't know why here is black. Yeah, but these are the outcomes that we got. And this, we can see here, we have the total nitrogen that we express in ppm, the available P, the phosphorus, the potassium, the soil organic carbon, the pH, the cation exchange capacity. And the table that you can see here, these are the statistical metrics of our prediction. And what we got is like the weighted average outperformed the splines method. And as you can see in our graph in figures here, we have a huge variability of the soil nutrients in Ghana. That means we should be able to predict accurately those maps to fit our model, because this variability is quite difficult to capture across the country. And this variability can really reduce the performance of our model, even though you are using machine learning. And this is a map that we try to categorize. Those maps that I just showed here, the total nitrogens, we try to categorize them to be able to come up with a recommendation. As you can see, in the northern part of the country, the total nitrogen that we express in ppm is range between 40 and 100 ppm. That means in the northern part, we have total nitrogen is more deficient. But in the northern part, we have quite, the soil is quite okay in total nitrogen. It's the same thing also for available phosphorus. In the whole country, phosphorus is deficient because from the literature and also from the experiment that have been conducted, fertilizer, the phosphorus recommendation should be at least, the critical value should be at least higher than 25 ppm to be able to say that our soil is not so deficient in phosphorus. And we have also exchange potassium. We have the soil pH. These are few that we try to categorize to show that we have a variability in terms of soil nutrient in Ghana. Then we have to be able to map it well before to use them to fit our model to predict yield for government decision making for maize or rice importations. And this slide shows us the comparison that we made between the ISDA soil grid. The soil grid here is ISRIC, and the AA is the one that we have produced ourselves. And you can clearly see that for clay, sand, silt, soil pH, and cation exchange capacity, we have very low root mean square for the map that we produce. And also the mean error are low for our maps compared to the ISDA. Then it is good that we can rely on ISDA or ISRIC maps, but still it is really important to have a soil information system locally, as even Dr. Ermias just mentioned, to have a local knowledge, to build a local soil database or soil information system that will guide fertilizer recommendation, to guide farmers and how to apply the fertilizer. And also, we show that soil maps is important, but in our team, we are using those soil maps in our different model. It could be linters, it could be VSAT, it could be AFSIM, to predict, like to have a special predictions of yield or yield gap over the country. And we all know that in West Africa, specifically in Ghana, these are we have a lack of such kind of map that will guide policy. And we, in our case here, the map that we use it to feed our crop-based models and our machine learning models to come up with especially predictions of the yield gap. And as you can see here, we use the linters to predict, we couple the linters and soil data to predict the potential yield. And as you can see at your left side, these are the observed yield, the variability in the yield. And at the right side, we were able to predict the potential yield. And you can see that the gap in the northern part is very huge. And we have a huge correlation between this gap with also, for example, nitrogen contained in the soil, because in the northern part, the soil is very poor in nitrogen. And such kind of maps could guide people to see how we can narrow down the gap. For example, this map is for maize, how we can narrow down the gaps and what would be the strategies that we can use to touch farmers and incentivize farmers to apply the fertilizer that needed in the northern part, in the central part, also in the western part of the countries. And here, for example, we use also the same models to predict, to have a time series with productions, potential yield predictions in Morocco. Sorry that we cut the map like that. As you can see in the bottoms, we just selected in the, in the south part of the country where agriculture is more intensive. In the western part of the southern part of the country is more desert. Then we didn't really consider it. And as you can see here, we are able to predict the yield gap over the country, the potential yield gap over the country. What I mean the potential, I mean using solar radiations, light use efficiency to predict the map, using weather data. And here is also one of the articles that we published. This is for soybean. Is about to study the effect of sulfur and zinc in soybean yield and to analyze the spatial and seasonal yield variability in Ghana. And this is a map that where we use kind of different scenarios using ISDA data and also the data that we also produce to feed our models. A machine learning model was a conditional random forest to predict the soybean. And as on the top of those maps, we have, for example, from May to August, from July to October, we try to predict using the different amount of fertilizer that we applied. And as you can see here, this map tells us that in the northern part still we have low fertilizer, we have low soybean yield, but if you apply the NPK and S, and we also include inoculant, we can still get yield up to 2 tons per hectare. Then this is the work that we are currently doing in our teams. It's just a short overview that I just presented. And in a summary, what we can say about the soil information, we can say that soil information is critical for decision-making in West Africa, mostly to drive our agriculture, to help farmers to increase their yields, and also help the government in their policy. Because if you are not able to predict the yield wells as we have here, it's quite difficult for the government to have an accurate importation, for example, of maize or yield. In this will, this can waste the money, and this could also jeopardize farmers, or also increase the risk of farmers when they apply fertilizer or they don't apply fertilizer. Then thank you so much. We are open for your question. I just rush quickly to be on the times. Thank you so much.
Thank you, Kouame, for this wonderful presentations, and congratulations to you and your team for the wonderful work that you are doing. Trying to use advanced modeling techniques to come up with decision support output, which is going to drive our agriculture sector, and in Ghana and also in other parts of Africa. Thank you. Now the floor is yours, the participants, for your questions. Please, you can raise up your hands and then we'll give you the floor to ask your questions to Kouame. Do I see? Yes, I see Sam. Dr. Sam, please, you have the floor.
Okay, thank you very much, Kouame, for this interesting work in Ghana. So it's very interesting and well presented. I like it. So it's not a question to you now. It is more of just to commend the work and to also highlight, because you pointed out towards the end of the slide that actually the sulfur actually makes a difference, including the addition of zinc to maize yield in Ghana, trying to help to close the yield gap. And from some of the research we have conducted within the maize belt region of Nigeria in about 6 years ago, we also observed the same trend while working with OCP. We found out that, okay, when you have sulfur fertilizer, when you have sulfur included as one of the elements or zinc included, there's a yield response. So that implies, but most of the time we find out that when we do soil analysis, routine soil analysis, sulfur is often not determined.
Yeah.
Except you request specifically for sulfur to be determined. So it means that it's high time we change some of these narratives by actually including the determination of sulfur as part of routine soil analysis. And your result is pointing out that clearly. So I just wish to highlight that. Thank you very much.
Yeah, thank you so much, Dr. Samuel.
Kouame, would you want to react to Dr. Sam?
Yeah, I would like to add a quick of what Dr. Samuel said. Yeah, I think what Dr. Samuel says is right. Sulfur is one of the most important nutrients that people should pay attention to that. Unfortunately, when we are doing our soil sampling, analyzing our data, we are not paying much attention to sulfur or zinc. It is something that we should at least put in our routine, daily routine, to at least have a database for also sulfur. It's true in Ghana, maybe in all West Africa, we do not have much data for major macronutrients, but at least we can still start for like micronutrients for sulfur, also zinc, that could maybe help us to reduce the yield gap in those West African countries. Yeah. Thank you, Dr. Samuel, for the comments.
Thank you, Kouame. Dr. Kouame, please, you have the floor. You can open your microphone. Yeah.
Hello, Eric. Thank you very much for giving me the floor, and a massive thanks to both presenters for what they have presented. I just have a question for Dr. Kouame. If I understand well, he is presenting aspects of yield gap determination. I just wish to find out if he takes into account separate aspects like gaps that are linked only to nutrients gaps that are linked solely to maybe water and some other climatic variables. Because as you know, my worry is with the way farmers especially face the difficulty of climatic variations.
Yeah.
How can such models really come to give us not exact, but information that is very close to reality? Thank you.
Yeah, thank you so much, Dr. Kouame. Yeah, exactly. The model that we used was Lintor. Lintor is a summary model and is not considering soil data, but because we have Lintor 1, Lintor 2, Lintor 3, and so on. It's true in this work that I just showed here, I didn't show where we really consider the soils information into that means Lintor 2. And I'm still currently even working on Lintor 3, where we will considering nitrogen like a limiting factor. Yeah, we didn't really consider them in the model because the models was for potential yield, where we want to see what will be the field of maize yield in Ghana. Because, in Ghana, we have a couple of maize varieties, where from research, people say that this is the attainable yield, this is the potential yield. But we try to start from scratch and to see what could be this field. Then we use the Lintor that is based on use efficiency to see what could be in reality the field of this one. But we are still working on some model where we are involving the water limitations and the nitrogens and potassium and phosphorus limitations in our models. And also, I really appreciate that you mentioned the effect of climate in the yield gap. Yeah, exactly. We're about to publish one paper where we try to study the variability that we have when we use, for example, NASA power data or maybe DMET. When I say DMET, I mean the Ghana Meteorological Station, or local data, or when we use ERA5, which is the most used wafer data that we have in our prop-based models. And our conclusion was like using ERA5, our model tried to really be close to reality, what we have on the ground, compared to NASA power. Then, yeah, you make good to stress this one, that these are kind of work that are still undergoing. Yeah, thank you so much for coming.
Thank you very much, Kouame. I greatly appreciate. I ask this because if I take the local case here in Cameroon, farmers are in dire need of this information because it is dealing with, I think, with everyone. So they keep asking for, what can we do? When is the time to do this? How do we cope with this change and so on? So I really appreciate and I encourage you, please. We want to see them because it will be very helpful. So I wish you all the best with this work.
Yeah, thank you so much, Dr. Kouame.
Thank you.
Thank you, Kouame, for the reaction to Dr. Kouame's question. I think it's timely, and I would want to also stress on Dr. Ermias' last remarks that our government needs to come up with innovative approaches, how sustainably we can invest in some of these researches, which we need to drive our agriculture forward as a continent. And these are some of the things that we should be doing and investing when it comes to our African improving upon our agriculture. Dr. Alimata, please, you have the floor to ask your question.
Yeah, thank you very much, George and Eric, for your intervention. And thank you, Kouame, for sharing these important results on machine learning. I think we really appreciate it. And the results are quite very informative. So I think, like Eric said, we need to integrate this kind of study in our activities. And also, I think we can also write some policy brief just to inform the decision maker on the key result on this kind of let's say, activities. Because right now we are trying to integrate information, climatic information in agriculture. And I think that if we can fine-tune this kind of model by integrating the different scenario with, let's say, water limitation, we can come out with a very, very good result-driven tool to develop our agriculture. So I would really encourage you to see how you can fine-tune this kind of mapping and
Dr. Alibata, we lost you now. Okay, we lost Dr. Alimata, but I think Dr. Alimata's points have been clearly made, and she's calling for a collective approach, how we can work together to work in this direction of research. Any more questions or comments before we try to sign up? We are 12 minutes past our time, our schedule, but I think it's been a time well spent listening to these interesting researches from our speakers, Dr. Ermias and Kouame. We thank you very much for gracing the opportunity and sharing with us your experiences in this field, and for once again highlighting how soil organic carbon is important and how we need to manage it to save our agriculture. And also Kouame stressing on how advanced modeling techniques can also be implemented into our agriculture to help come up with decision support products which our policy makers can use to make decisions. We are grateful once again to our speakers and to all participants. We are also grateful to you. We thank you for joining us in this session. I think we've learned a lot. We've listened to great presentations, and we will look forward to the next showcase next month.